Okay. So in essence, what's so nice about this versus what we've learned in the past is that this one doesn't deal with cosine or tangent. It's just sine. Hence, it's the law of sines. We're just going to use sine over and over and over and over, okay? You're going to see why this is so unique. Okay, ready? Draw yourself a triangle. You can make it moderately sized, all right? Let's go a nice big triangle like that. Let's name our triangle. Jim. J-I-M. Good old American name. Jimmy. There are very few, I would say, Arabic names that are 3 letters. Is that true?
Yeah.
You guys have those?
No, there's one.
Nice. You guys have those beautiful long names.
Ali.
A-L-I. Oh, Muhammad Ali. Yeah. Oh, nice. Yeah. Okay. All right. What do you notice about Jim?
Jim is not right.
Very good. That's what I wanted you guys to see. It is not. Yeah, Jim is not right. That actually works out great. He's special, indeed. Not 90. Not 90. Hey, wait a second. Everything I've taught, we've had every triangle's been 90, right?
Yeah.
So watch how this is so unique. Okay, so the first thing you have to learn is this weird lettering system. Watch how this works now. If this is J, okay, basically this guy right here is J.
Yes.
The leg opposite of J is which leg?
M-I.
M-I, but now we're going to give it a special name. We're going to call it lowercase j.
G.
Hence, watch how the pattern works. You guys see capital M? Which leg is opposite of M, which is what I'm asking?
Lowercase there.
Lowercase m. Again, some people aren't getting this opposite, and that's totally okay. Just think about the leg that does not touch the angle. So using that idea, what leg does not touch angle I?
MJ.
MJ, oh, MJ, that's a very famous initial for people who were raised in the city of Chicago. Michael Jordan, number 23. There you go.
Mary Jane.
Mary Jane, yes, that's used as a reference to many different things, yes.
Spider-Man.
Very true, very true. There are ski runs actually named Mary Jane, saying good luck trying to get down this. Okay, good luck because it's so hard. Right? Okay, watch how this works. This is really goofy, but here we go. Let's write it down. This is the rule. This is what you will use, but you will fill it with numbers and values. They go like this. The sine of angle M divided by its leg is equal to the sine of angle J divided by little j.
Oh, so it's capital M divided by M.
Yes, very good. So guess what? It's sine of capital I divided by
Small I.
little I. So class, if I can have you hone in on this part right here, that is the law of sines right there. You're going to see how this works. I know it looks a little strange, but basically as your teacher, here's what you will do. You're going to make a proportion equal to another proportion and cross multiply like we have been doing over and over and over, okay? I know. It's just, remember, you're getting empowered. I'm giving you a gift that nobody can take away. Wisdom. Knowledge. I heard some chuckles in the room. No? No, not? What gift would you rather me give you? Like cookies?
Chocolate.
Chocolate, but that's going to only last for like 30 seconds, then it's gone.
Sure.
So I get to give you a gift that lasts forever. Okay? So, just reviewing, there we go. Key to what we're learning today. A, triangles are not 90, and we have these weird fractions. Like put a box around this just so you guys get it. That's like the theorem. Not a theorem, it's a law. That's what you will be doing, okay? All right, so here we go. I'll show you through a couple examples. You're definitely going to need a calculator out, so get one out right now if you do not have one. Whether it's phone or iPad, you just need a trigonomic calculator. Everybody make sure that calculator is in degree mode, right? Degrees because we're inside of a triangle. We're doing degrees. The wind's blowing them all. Thank you, Ben, for picking that up. Once you are ready, we are going to call this example number 1. We are going to learn how to apply the law of sines.
Is this going to be on the quiz?
This will be on the quiz.
Great.
Wait,
Wait, so in the quiz next class we're gonna have also what we're doing today?
Watch how easy it is. I say that and some people are gonna be like, Mr. Yates, you're full of crap, but it's okay. It is easy. Here we go. Draw yourself another non-90-degree triangle. What triangle name would you like to give it now?
Kim.
With that
Can't do Bob, because we can't repeat the B's.
Bob.
Kim.
Dab.
Kim, like K-I-M.
Dab.
I have a cousin named Kim, actually. Oh, Kim Kardashian, yeah, good point. Okay, here's what we know.
Kim Jong-un.
Yes, a lot of Kims out there, very true. One of them happens to be a leader somewhere.
Somewhere. It's a very good.
162 degrees. Class, that means that is a giant angle. Everybody pay attention to that. That's an obtuse angle. Okay? Opposite of that is 55 millimeters. That is the length of MK. So notice how they're not doing letters now, but they're doing angles. Okay. Your good friend, triangle sum theorem will come into play here in a second. Hold.
162
Go.
divided by, no, close it. Sine.
He's already doing it, but it's okay. I need a real small angle. What do you think a real small angle would be?
Oh my god.
Oh, hey, we did someone said MJ. Nice, yeah, you got that. Let's make that 23 for Michael Jordan. Hey, class,
What?
what you're going to do now is you're going to solve this. What does that mean when I say solve this? You find every missing part. Angle K is oh my gosh, Mr. Yates did not think very good. You're going to see why in just a second. If you have 162 and you have 23,
That's 185.
I've exceeded the triangle. This is called a YouTube failure video. We are going to have to manipulate.
Teaching class gone wrong.
Yes.
Must watch.
So, remember, there's one rule in this world that I live by. If you cannot laugh at yourself, there's something wrong with you.
10.
Okay. 10 is way better. Now it'll work. Very good. Make that 10. Okay. So here we go. Watch how you do this. First example of ever doing this. Here we go. Sine of 162. So sorry. Everybody, you're going to make a fraction. So first, before I even do this, put a big old equals and put fraction, fraction. That's what you're going to create, okay? You're going to create basically two equivalent fractions. So you, as a student, figure out what's on the left, what's on the right. Here's how the law of sines works. Sine of what? Very good.
162
162.
divided by 55.
Right, so you're taking the angle divided by its side. Now watch how you do this. You take this
10.
and then divide it by that. So the other fraction will go like this. Sine of 10. Not x, we're gonna, yes, very good. Little m. Why did I pick little m? Yeah, and that's how you know what side you're solving for. Instead of just putting x and y's, you're actually gonna say that's the side that corresponds opposite of the angle. Yeah. We're gonna cross multiply. Very good, class. I hope I've done enough work with you with similarity about this. What do you do when you see this now?
Don't we have to put the sign of K?
We will. We'll do that next. Yes, very good.
Cross multiply.
Cross multiply. What does this look like, class?
Sin 162.
Sin.
Or
M sin 100. Yeah.
Good. Let's all write it out together and make sure everybody learns. We got it. Here we go. Bottom left, top right. Terrible terminology as a math teacher. Really, you're doing denominator versus numerator. Okay? And then vice versa. Bottom right, top left. And they are equal to each other. So many people always kind of, hey, do I add them, subtract them? Nope, they are equal because you have proportional fractions. Okay, if you are trying to solve for m, what will you do actually?
You will
9.5.
divide it by n.
Yeah, believe it or not, you will divide it, yeah, of 162.
It's to leave the m alone.
Hey, let's all practice this and type this in together and make sure we all get the same decimal. How does this work? Here we go. Pick up your computer systems and type in 55. Go 5 times sine 10, enter. Then divide that by sine 162. And let's make sure that we all have the exact same decimal.
30%.
30.9.
What digit do we always round to with trigonometry? To the thousands. We're gonna go to the thousands, so that's 3 digits. Well, how would I write this then? 30 point.
It's the same thing, except I think you missed like.
Class, make sure the screen in front of you has 30.90655 and you have rounded it up.
I got 30.580.
Close enough.
No, it should be perfect.
See, I would have given you an 8 on that because you were close. I'm gonna be a teacher when I grow up.
Nice.
What did we miss over?
And it's Matthew, right?
Yes.
Hey class, Matthew has 30.580 and that's impossible. Why? What's going on? No, he typed it in perfect. It is on what mode? Ah, you always got to make sure you are on degree mode. Very good, degree mode. Thank you, Matthew, for saying that. Now now you'll be perfect, buddy. Good, good.
That actually makes sense.
Okay.
Rad.
Please remember this from last unit. If this is 10 and this is 162, you can, that has to be 8. So this is not to scale at all, okay? That has to be 8. So class, this is a good moment to understand. You will have to get that one all by yourself. And you just use triangle sum. The 3 angles have to add to 180. Because guess what? Once you have that, you can now find this missing side, right? Because once you have the angle, you can find that side, okay? Okay, hold on, let's all do it together.
Why would we do that? Why don't we just do Pythagorean theorem and done?
Not right, very good, it's not 90. Oh, excellent question, sir. When's the only time I can use Pythagorean's theorem?
Right triangle.
It's gotta be right, this is not 90. Hey, so as your teacher, here's what I'm trying to show you guys. You're going to use the fraction twice. So everybody look here to the left, right? You have all this work to find m. Now you're gonna do the whole thing again, but not with m, but with a new angle. So watch this. So everybody, sine 162 over 55. What does it equal now?
Sine of
The sine of what now? 8 over?
K.
Yes, little k. And class, that is what you wanted to learn. Is that the idea that we're doing now is you will do this twice, right? You will find both legs. And the key that I want to show everybody is you will use it twice. All right, I want to emphasize that. You use that same proportion again, okay? All right, go ahead and cross multiply this one more time, right? Practice it one more time. So I go 55 times the sine of 8
Multiply by sine of 8.
equals k times sine 162.
162 divided by sine
Why don't
162.
why don't we put the measurement that we found before instead of K?
Did you get 80?
The measurement we found before is a rounded answer.
But no, before we found Ki, right?
Okay, so I'm with you. So the first thing we did was found that m right there.
Yeah.
Now we're trying to find this little k over here.
Before we found M.
Right.
Yes. So why don't we use
You
M?
were wrong anyway in the first one.
M is a rounded answer. So we never want to use a rounded answer to get a new answer. That's why we use
You get
that.
25?
So if we ever get a round answer instead of using that, we put K.
You're going to get the right answer, but it's going to be a little bit off. So what to learn? Hey, shh, guys, class. Shh, this is a great question. Whatever information they give you, you want to use that one only.
Oh, okay.
Right,
So whatever we find, we just keep it
right,
there.
right. Don't ever use your rounded answer to get a new answer. I mean, I know you guys you only be off by a couple decimals, but when you build things off like millions now and thousands, like when you're scaling things, rounding is very yes. 'Cause now you're off by like 1,000 something, yes. Okay, what do we get, guys? 7 point what? 65?
4.771.
Excellent. Our button pushing is solid. We're good to go. The great part about the law of sines is that it's not much more advanced than just this. So this is a nice little addition to add on, okay? Obtuse, trying to look at that. The obtuse wins. Let's make it a nice big obtuse. Oh, looks oh so close to 90, but it is not. It is going to be 93 degrees. All of our theorems are out the window now, except for the law of sines. Okay, but watch what they're going to do. They're gonna say that's 93. This is 130 centimeters. And then they're gonna tell you this is 34 centimeters. That's it. And they're
Let's
gonna,
name the new one.
they're gonna, oh, let's name it, sorry, of course.
Dig.
Dab?
No.
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 Yeah, dabs.
No.
Wax.
Dab.
Anna.
A-N-A.
Can't repeat letters?
Ant.
Wax.
K.
Clock.
A-N-T. No.
No.
Nap.
Yay.
Nah. Some of you going to DO next week that will be near the ocean, you will experience the sea gnats.
Yes, those are miserable.
Yes, they are fantastic little creatures that just bite you until you want to die. No seams. Very good, sir. Yes, no seams.
I don't know.
Don't worry about it. Hey, shh. Attention. The triangle up front. Hey, everybody, eyes, ears. Hey, what's the problem with my angles?
You don't have like 2 angles.
I don't have 2 angles. Please, shh. Learn this. You don't have another angle, so you can't unlock the third. There's going to be something happening. Instead, they gave you 2 sides. Wonder why they did that.
Reverse it.
To reverse it. Everybody watch this. If you don't know an angle, what do we say? We call it what? Yeah, theta. Very good. We use Greek symbols to represent angles. Class, I'm going to show you how you can use the law of sines to find an angle. Now, if I created this problem correctly, hopefully this will work out. Sometimes this does not work out. These are hard to make up on the fly. Here we go. So a good proper teacher would have had this done before class, so it would have worked. We're going to find out. Oh, I got thumbs up on that. Here we go. Class, this is what I need you to do is using that beautiful brain of yours. If this is the angle, that's opposite. So guess what these 2 things do to each other? Sine. That's how the sine connects to them, right there. So watch how you set this up. Make this nice and big so you can learn from this. The sine of, I'm going to use what they give me first. 93 over. Very good. So you're getting that opposite thing locked down. The angle on the opposite leg is equal to, watch what I do now. I'm going to actually put the sine of A, because I don't know it, but that's where I would have put the angle if I did know it. Over what?
34.
And you're going to be able to find the angle. So the key lesson of today's whole teaching, I can find missing sides and I can find missing angles. Watch, very good. What are you going to do when you see this thing? Things are equal. We do what every single time? Very good. Everybody put 34 times sine 93. What does that equal? 130 times the sine of A. So you're following along. You're seeing this setup. This is how the whole thing works. Okay? What am I trying to solve for? Yeah, this angle. Don't keep that in mind. I'm finding the angle. Okay? So guess what I do? Okay, I'm going to need you to really follow along now with your button pushing. Okay? So here we go. I'm going to zoom this in so we get this nice and clear. Right? Everybody type that into your calculator right there.
I don't want to play Game of War. Oh my god. Tutorial. Oh yeah. I can't.
So here we go. Can everybody please hit 34 times sine 93? Then just hit enter for me, please. Then hit divide 130. So we're using that A&S feature over and over and over now. Do you have a decimal?
Yes.
Is that decimal less than 1?
Yes.
Thank the good Lord, my example works. Hey, you're trying to find an angle inverse. Everybody hit this exact command, hit second
Did you get 0.26?
or shift and sine. There's a little inverse thing pop up.
Yes.
And then use that decimal, then hit ANS, right?
Yeah, yeah. The second
What do you lost?
ANS.
Answer. 15 degrees.
Wait, so what do you do?
Where you lost?
At the second block.
Okay, do you have this decimal staring at you?
Second. Yeah.
It's 0.26.
Now hit second, sine, second, negative. Enter. And please make sure that you can see on your screen 15.14. The angle is 15.14 degrees. Very good. Everybody pick up your pencils, write the final answer. Angle A is 15.14. I'm going to give you a chance to practice it again. Yes, ma'am.
So are we dividing by 100? Why are we dividing by 130?
That's a great question because,
And not 34? Because
yes.
the other one we don't have.
I know, but we're trying, see the laser right now?
Yeah.
You're trying to find that.
Okay, so.
So we're isolating this.
Oh.
Yes, very great question. That's why we're dividing by the 130. So important. So important, okay? All right, now here's the bad news. Can't use a rounded answer to get my next answer. So I have to do it again. I'm gonna let you practice this again, okay? All right, let's see if I can do this now. Here we go. Class, everybody, eyes on the front board. Look where the laser is. How do I find that angle? Well, wait a second.
We don't have the sign.
I need that side.
And it's not 90 degrees.
Right, and it's not 90.
So I have to find the side.
I gotta find the side. How do I find the side? Whoa,
But
Mr.
wait,
Yates, how is this all supposed to work?
since you had the two angles.
Yes. Very good. I'm going to let you actually do this now to save us some effort. You're gonna just use that and your brain, because you know this. What do all three angles have to add up to? Very good. So I know if I have 93 and I have 15.14, it's rounded, but we're gonna just live with that for now. Yes, very good, Ben. Take 180 minus that. Take 180 minus that sum, and you will figure out what your missing angle is then.
91.8.
Very good. So 71 point, yes, degrees. Now, once you have that 71.86, can you now find this last missing side?
Yeah.
Yes, because you have the angle that's opposite, okay? So, let's just verbally do this, don't have to do it, put your pencils down. What would be the proportion you set up to find the last side? Sine 93 over 130 equals?
Sine 71.86 divided by t.
Divided by little t. Very good, divided by little t. Let's go through that one more time, just so everybody gets it. You take what you know. It's so true in life. Take what you know and use it. If not, good things and bad things happen. What does that equal, right? And what you're gonna do is use your rounded answer. And just for simplicity's sake, we're gonna let you. Right? If this was a higher level college course, they would make you do all sorts of different work, but we're good. As your math teacher that has to teach you all this complicated stuff, I'm so happy to tell you this is it. There's nothing more to it. You just do all these crazy proportions and you find angles and sides, and that's it. There's no like if, ands, but, oh, but what if this happens? Oh, nope. It's really simple. If the angle is not 90, if you have no 90 degrees, you use law of sines. And it's your whole premise of just making that opposite leg. Okay, you can go through it, set that up, walk yourself through it, and then we are good to go.
Okay, I'm done.
You're done?
We're done with the day?
Halas?
123.7.
No.
No. Okay, I have one question.
C.
You're dividing it by t, like over t.
Yep.
So t would be 34.
No.
Because it should be the missing the leg, right?
Okay, good, but it's this missing leg.
Yeah, but why would we name it t?
Ah.
Because it's
It's another
opposite,
t.
right? Because it's opposite.
When you can answer your own questions, it's beautiful. Hey, what'd you guys get for that leg?
123.708.
Bravo. How do you say perfect in all the different languages you speak? Perfecto. Perfect. How do you say perfect in Arabic?
Mumtaz.
Oh, that's beautiful.
In Australia, it's just bloody good.
Bloody good?
Very good.
Or, don't I have more UK people in here?
Job.
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 He's not from the UK.
Yeah.
No, he's not. He's not British.
Jobin is.
Jobin is. Yob. Oh,
No, Yob is
Yob is-
from
Europe.
He's
Dutch. Dutch feller.
I always use Europe.